Algebra 2, welcome. It's week 7 and it's the second assignment. We're going to be continuing with some rational functions, and now we're going to be looking at canceling even some more factors, maybe simplifying some multiplication. Things might get kind of hairy, but don't worry, they will work out. So I've got some steps. I like to type up a little bit of steps in case you're the person who likes to, cross things off a list as you go through a problem. So these might be some steps that you would want to write down or, copy, save for later. So this whole section is all about like multiplying and dividing. Today we're just going to look at multiplying rational functions, rational equations. And so if asked to, I just want you to multiply straight across, all right? Just like fractions, you just multiply the numerators together and the denominators together, all right? And then factor whenever possible, because you're going to be multiplying polynomials, and if you can factor them into like linear factors, that's going to be very easy, all right? So maybe you had like x squared minus 25, all right? This is a difference of squares polynomial, and if you remember, there was a little formula for that, or you can just, do it in your head. I remember difference of squares. I could write this as x plus 5 times x minus 5. So that's an example of, factoring, all right? And then simplify by canceling out some factors, all right? So maybe, let's say you had x plus 1 divided by x plus 1 times x plus 2, right? My x plus 1 on the top and the bottom, right? They cancel out through the same factors. You can just write this as 1 over x plus 2, all right? So it simplifies a little bit down. And then it says, write the simplified function like I did right here and its restricted domain, all right? So because I have a x plus 2 in the denominator, that means that my function, 1 over x plus 2, my x value cannot be equal to negative 2, because if you plug in a negative 2 into that denominator here, that's going to make the denominator 0. But we also had this original, even though it canceled, it's still kind of there, right? So we still also have to say that x cannot be equal to negative 1, all right? So I'm going to add that on to the end. So we wrote the simplified function, and we're writing the restricted domain, x not equal to negative 2 and x not equal to negative 1. All right, you have to include both of those terms. Even though one of them canceled, you do have to include both of them because they're still in the denominator. Again, let's look at some quick examples. So this is just a numerical example before we throw some variables in there, all right? 36 times 1 over 48, you multiply straight across, that's 36 over 48, all right? It's like 36 over 1. You just multiply numerators together, multiply denominators together. Boom, there you go. If you want to simplify this even further, again, step 2 was factor if possible. Can I factor 36 and 48? Yes, you can. You can factor it into 3 times 12 divided by 4. Oops, that was supposed to be a 4. 4 times 12, all right? And then I see my third step here, simplify by canceling out some factors. Well, I got a factor of 12 and 12 on the top and the bottom, so those cancel. And hey, my fraction is really just 3/4, all right? So that would be my simplified version of this multiplication problem. And since we don't have any variables here, we don't have to worry about domains because it's technically just a number and not a function. So we're going to move on. Here we go. So keeping those steps in mind. First, multiply straight across. Okay, well, let's just say I've already multiplied. We're just taking this slow. The next step would be to, sorry, I just got a text and it distracted me. Factor if possible. Well, it's already factored, right? It's already factored into these very linear factors here. And then we say, can we cancel anything? Yes, we can. We have a factor of x plus 4 on the top and the bottom. So those would cancel out. So I'm really left with x plus 1, right? There's nothing on the top. There's nothing on the bottom. I've already canceled it all out. This is technically, even though it looks pretty confusing right here, this is technically a linear function. All right? It's technically a linear function, but since we had x plus 4 in the denominator, we still have to account for that and restrict its domain. So if I say x plus 4, again, we got to check that that thing's not 0. So what value would make that denominator 0? Well, I set it equal to 0 and solved for x, and I got x equals -4. So the value -4 would be part of its restricted domain, right? And we were writing domain with like set brackets, and that's totally nice. You could also on the end just say, you know, this little comma, x not equal to -4. So all in all, this function would simplify down to f of x equals x plus 1, but my x value cannot be equal to -4. Again, if you want to think about it, this is like a linear function. So if this is my coordinate plane and here's my line, except, wherever x is equal to -4, there has to be a hole there. All right, so that's essentially what it is. Let's move on to some harder ones, all right? Example number 3, simplify. So again, let's just assume I've multiplied things. We're just starting simple. Can you factor this out anymore? Let's focus on the top, all right, the numerator, the polynomial x squared plus x minus 6. Let's see if we can just factor this out. What two numbers would multiply to be -6, but would add to be a positive like 1? Well, you would factor this out to be x plus 3 times x minus 2, all right? So the top factors very nicely. What about the bottom? Well, the bottom here I have, this is difference of squares. I recognize that 9 is like 3 squared, right? And I have this x squared, so I can factor this out. Just like what we did up before with our example, I can factor this out to say x plus 3 times x minus 3, alrighty? And then I say I factored it out. My next step is, can I cancel anything? Is there anything on the top and the bottom that I can cancel? Yes. This factor of x plus 3 is on the top and the bottom, so that can cancel. And now I can write my function f of x. It just simplifies down to x minus 2 divided by x minus 3. And that's a rational function. But again, I've written my simplified function. I also have to write my restricted domain after it. Again, if you want to put it in like set notation and say x, you know, such that x is not equal to, in this case, it would be -3 and a +3. Or you could just add a little comma at the end and say, all right, let me look at my two factors. What would make x plus 3 equal to 0? Well, it would be the value x equals -3. And what would make this factor x minus 3 equal to 0? Well, it would be the value 3. So you could add in x not equal to -3 and x not equal to +3, all right? So it looks kind of crazy, but it simplifies down to a nice rational function, but just with a restricted domain, all right? Okay. Now we get to some multiplying steps. So I've already kind of factored everything out for you. I did the easy stuff, but we're just going to step 1, multiply straight across, all right? So I'm going to multiply through all of my denominators here. So that's going to give me on the denominator, or excuse me, on the numerator, 4 times, okay, so that takes care of this factor of 4. I also have an x, so 4 times x. I like to write the parentheses stuff at the end. So then I have my last two factors, x minus 8 times x plus 5. I'm just crossing these out as I go because there's a lot that I'm writing, so I want to make sure I'm getting every one of them once. In the denominator, I have, again, I'm going to start with that nice 4, all right? And it's also being multiplied by x, so 4x. And then what are my last two parentheses terms? It's x plus 5 and x minus 2. Okay, I've multiplied straight across. There's nothing to factor since it's already factored for me. My third step is, can anything cancel? Is there anything on the top and the bottom that will cancel? Yes, there is. Okay, let's take a look. I got a 4 on the top and the bottom. And honestly, those just cancel right now. And we don't even have to worry about it because it's not a variable. There's nothing that there's no like x value that I would plug into 4 because 4 is just a number, right? It's just a constant. It literally cancels out. It's 4 over 4. It's just 1. Okay, so we don't even have to worry about that guy. what about the x? Yeah, this x value is on the top and the bottom, right? And I'm just going to start writing my restricted domain as we go. So here, my x cannot be equal to, or excuse me, in my restricted domain, yes, x cannot be equal to 0 because what value would make x 0? If I plugged it in, well, it would just be 0, right? So I'd have to include 0 in my restricted domain. The next one, I'm just looking at the denominator again because that's the interesting part. X plus 5, is there a factor of x plus 5 on the top and the bottom? Yes, there is, and I just canceled them out. I would also have to include, so if I did x plus 5, if I set that equal to 0 and solved for x, I would get x equals negative 5, so I would have to include the value negative 5 in my restricted domain. My last one, x minus 2, is there an x minus 2 on the top? No, there's not, but again, it's still in the denominator, so even though I'm not canceling it out, I still have to include it in my restricted domain. So I could easily just say, set this equal to 0, x minus 2 equals 0, solve for x, and I get x equals 2. So I'd also have to include 2 in my restricted domain, all right? So this really simplifies down to x minus 8 divided by x minus 2. So I'm going to rewrite my simplified equation, and this is going to be x minus 8 divided by x minus 2, but x cannot be equal to 0, negative 5, or 2. Okay, we're doing good. We're doing really good so far. Let's move on to our last one here. Example number 5. This is going to include all of our steps. So, step 1. I'm multiplying some rational equations here. I'm multiplying them together. So we're just going to treat them like fractions and multiply straight across. All right, I'm going to take this step by step. I'm just going to multiply straight across. So this is equal to, the first polynomial is x squared minus 3x minus 10 multiplied by my other numerator, x squared minus 16, divided by, and then in my denominator, that first polynomial of x squared plus x minus 20 multiplied by x squared minus 4. Okay, check. We've multiplied straight across like a fraction. My next step. Does anything factor out nicely? Let's check it out. Okay, I'm going to take this next screen here and say, all right, let's focus on this polynomial right now. X squared minus 3x minus 10. It's in the numerator. Does it factor out to be two linear factors? What are two numbers that multiply to be negative 10, but would add to be a negative 3? Well, I mean, you sit there and think about it, make sure you can figure it out. It would factor out to be x minus 5 times x plus 2, all right? So that's the first polynomial in our little rational equation. Now let's focus on our second one in our numerator, x squared minus 16. And again, here I can recognize that 16 is a perfect square. I know that 4 squared is 16, and this is a difference of squares, so I could write this as x minus 4 times x plus 4. Okay, that one factored out pretty nicely as well. Now we're done with everything. We're done with everything in the numerator. Let's focus on things in the denominator. So I'm going to highlight this next function, our first one in our denominator, x squared plus x minus 20. Again, let's think about what two numbers would multiply to be negative 20, but would add to be a positive 1. All right, and it would be x plus 5 times x minus 4. Okay, that takes care of factoring my first polynomial in my denominator. And then I can say, all right, what about factoring that last one, x squared minus 4? Again, I'm seeing some difference of squares here, right? Difference of squares. I'm subtracting x squared, and I'm also subtracting 4, and 4 is just 2 squared. So I could write this bottom one as x plus 2 times x minus 2. Okay, that was a lot of factoring. We did very good. What's our next step? It's all factored out. Let's see if things are going to cancel. So again, the interesting part is the denominator, because if anything in the denominator is equal to 0, That's not a good thing. You cannot be dividing by 0. So I'm just going to run through all of my factors here in the denominator and check if anything cancels or needs to be added into a restricted domain. So my first factor here, x plus 5. Is there anything in the numerator that we can cancel? No, there's nothing, right? But I still have to make sure that x plus 5 is not equal to 0. So what value would make x plus 5 equal 0? Well, if I solve for x here, it would be x equals negative 5. So I need to include x equals negative 5 in my restricted domain. What about my next factor, x minus 4? Oh my gosh, that one's easy. There is a factor of x minus 4 in the top that's going to cancel. And again, setting this equal to 0 and solving, you're going to get x equals 4. So there's another value for my restricted domain. What about x plus 2? Boom, right there. Canceled out. Setting x plus 2 equal to 0 and solving, I'm going to get x equals negative 2. So there's another value for my restricted domain. What about x minus 2? Nothing in the top, right? But again, still I have to account for its value, so I'm going to take that and set it equal to 0, and I'm going to get, when I solve for x, adding 2 to both sides, x equals 2. That's another value that I need to include in my restricted domain. Again, these are all values that x cannot be equal to, right? So this thing is going to, oops, there it is. Okay, I'm going to highlight the factors that are left. This thing is going to be equal to x minus 5 times x plus 4 divided by x plus 5 times x minus 2. So writing this simplified a little bit more is going to be x minus 5 times x plus 4 divided by x plus 5 times x minus 2. Again, in our restricted domain, x cannot be equal to negative 5, 4, negative 2, and 2. All right, so we multiplied, we factored, we canceled, and we simplified. Fantastic. Hopefully you guys enjoyed 7.1 where we talked about some triangular numbers. I thought that was kind of cool. I really enjoyed it. Look forward to some more of those lessons. Anyway, have a great day, you guys. I will include a couple more problems for us to practice. I mean, it's essentially the same thing where we were canceling, we're finding holes or vertical asymptotes. We're just doing the same thing, but now we're throwing in multiplication. So have a great day, guys, and I will see you later. Go team!